Today we're going to be working with this, a transistor. On the left side we have a connector, in the middle we have a base, and on the right side we have an emitter. It's going to work in correlation with our breadboard to create systems that are going to dictate whether this bulb lights up or not. We want to think of this transistor as two diodes put together. With that knowledge, this should be capable of turning this off at the request of one jumper cable, or two, turning this off in transition with another transistor. What does that mean? Well, let's find out and build a couple of systems. We're going to be focusing today on a couple of gates, one known as AND, where two transistors work alongside each other to turn that bulb on. We're going to be looking at an OR gate, where only one transistor really is needed to turn this on. And lastly, we're going to be looking at a NOT gate, which means even though there's one transistor, at the request of it and one jumper cable, they shouldn't turn on. Let's get into it. Here's how we're going to go ahead and build our AND gate. That means that we're going to need two jumper cables working in correlation with our switch so that they can both turn on at the same time. And to know that this is working, we're going to be needing an LED, as well as a breadboard, obviously, our power source, then connected to our 9-volt battery. Once we have that down, we're going to need 3 of these jumper cables, preferably smaller ones as their connection won't be very big. And then, of course, what we're working with are transistors, just as such. And lastly, a 1K resistor. Now that we have all of those in play, what we want to go ahead and do is start off with our breadboard in the right positioning. And today we're going to go ahead and start it from the number 1 all the way into the 30s, instead of starting from the 60s all the way to the 35s. So we're starting with this side of the board. Once we have that done, what we want to go ahead and do is take our power source, which needs to be set in a specific manner, right? We want to make sure that this button, the switch, goes towards the outside. And we're going to do this very carefully, placing it as such at the very top of our breadboard. Once we've achieved that, and we know that the button is all the way right up at the top, we got to make sure that our ends are at the positive and negative, which they are, and they are over there. That means this is ready to be set up. I'm going to go ahead and connect my battery over into my power source, so that way we have a working breadboard. I'm going to go ahead and take my resistor, and I'm going to go ahead and insert it within the 19th, which should be right around here, positive 19th on the left side of the board, going into the 23 row C category, if I'm not mistaken. So 23 to 1, 2, 23, there we go, right here. Blam. Okay, sweet. So setting up my resistor, it should look as such. Once I continue onward, what I'm going to go ahead and do is take a jumper cable and connect it right next to the side on C, still on 23, just there, with its end finishing just below 25 or 26, still in the same column. So it's going to look a little bit funky, but this is what we have, a connection just as such, right? A few spaces down, I'm going to go ahead and put my jumper cable number 2, and this is going to start at 32C with its tail ending at 34, 31, yeah, 30, about 34, if I'm not mistaken, right here. If not, okay, let me correct this one. It's going to start at 32, finish at 34, my mistake. So what we should have should look a little something like this. Sweet. Sweet. Okay, let's move on. The next thing that I'm going to go ahead and do is take this white cable over here, and I'm going to form a connection between end 1 and end 2 of my jumper cables, which should start at column E, row 26, finishing at column E, row 32, right? So connection is established between the two jumper cables as such. Then what I'm going to go ahead and do is take my LED, and I'm going to make sure that the shorter side goes to the negative. That is a matter of 37 to 35. There we go. Placing it as such, we got that. Now, obviously, it's not lit, right? I can turn my power source on. Nothing is going to happen. And why is that? Well, we need to work with our transistors. Your transistors can be incorrectly placed if not for you looking out for the signs. If you can notice, there's a cylindrical side to it and a flat side to it. The flat side to it will be facing outwards with the cylindrical side facing ourselves. In the 3 prongs that we do see, we have a connector, we have an emitter, and we have a base. The connector is going to be found to the left side, whereas this one, the emitter is going to be found right over here at the other extreme on the right side. The base is going to be in the middle. What we're going to go ahead and do, having the cylindrical part face us, is insert this within our connection. So this is where it gets a little bit tricky, and we have to be very careful in doing this. What I'm going to go ahead and do is take 1 prong and insert it right at the end of my black cable. Now again, I got to be very careful because I want to make sure that I'm doing this right. Okay. There's number 1. Let's go ahead and do the same with number 2. As I mentioned, this has to start at the end of my black jumper cable. When I've put them on, it should look like that. And once I press my power source, this is going to turn on. Why is this an AND gate? Well, let me tell you. These both need to be placed so that the current works. If I were to take this one or this one out, this would turn off. In this case, let's try it out with this one. Once I disconnect it, what happens? The light turns off. Okay. Let's try it with the other one. I plug it back in. If I take this one out, it turns off. They both need to be on in order for my light source to work. Let's continue on to an OR gate. Again, we're going to go ahead and have the same setup that we've done in the past before, where it's going to be your power source connected to our 9-volt battery, right? Same materials, so no need to go over that. Let's go ahead and get into building it. Of course, you want to take your 1K resistor, and you want to go ahead and start it off at the 19th mark on the negative left side of the breadboard, with its end concluding over in the C category, right at 22, just as such. So we're going to go ahead and start it off with a simple connection just like that, very similar to what we had before. To continue on forward, we're going to go ahead and take one of our 3 jumper cables, and we're going to go ahead and place one of the ends right alongside it, again in the 22 category, this time in the B column. We're going to go ahead and put its end, though, just underneath 30 in the very first column, or the second column rather, A. So it's going to be a little connection just like that, right? If we continue on forward and we include our second jumping cable, we're going to go ahead and put this jumper cable at the 34 mark right here at the very end, with its other end at the, what would this be, the 27th mark right over here in column E, right? So that we have it just set up like that. Good. Now again, I know it gets a little tricky, so you have to be careful where you're placing these pins. That's why I'm taking my time with it. One more time, I'll remind you as to the transistor. We want to make sure that the flat side, not the cylindrical side, goes to the back. And this, we're going to go ahead and start off at the end of our black cable, just like that, in column E, row 22, all the way to row 24, just as such, right? The other transistor is going to get a little bit funky because this is actually going to be placed not in the same column as our original one, but just below the white one in column D. Once we've inserted it, again with the flat to the back, it should look a little something like that. Now it looks a little bit jumbled. It'll start to make sense in just a bit. Once I go ahead and place my LED again with the shorter side at the negative, at the 35 mark, with its end right next to the jumper cable in column B, just like that. This is where this is going to come into handy. This cable is either going to make it so that this cable or this LED, my mistake, lights up on behalf of this thermistor or this transistor. I meant to say transistor, my mistake. We're going to go ahead and start it off with the very first one, and that is we're going to place our end here and our end right over here at the white. Let me explain it a little bit more. One end is going to start at the 22 row in column D, just right next to our original cable. And the other one is going to end up right at the, 23 mark next to our white cable, if you guys can tell. When I turn it on, obviously, my light is going to turn on because there's a current within this section, travels from one side over into the other. If I disconnect it, of course, it turns off. But here's the cool part about this. This is turning on behalf of this, right? What I want to go ahead and make sure of is, if I disconnect it, can I instead transfer the other end to the white cable and make it so that it runs on this transistor? Yes. So one more time, go ahead and look at that. On behalf of this is lighting up. If I disconnect it and I instead transfer it back to our initial position, in which current runs to this transistor, this will still light up. It's an OR variation. Now, last but not least, we're going to be building a NOT gate. That means that once we have one connector applied over to our transistor, it should not turn on. We're going to go ahead and set this up as we've done with the previous two gates by again putting our power source at the very extreme of the breadboard with a 9-volt battery hooked up. Okay, now that we got that done, we want to go ahead and start off with our 1K resistor right over here. Right where I'm going to go ahead and place this at is going to be at the negative left side of the breadboard, one end, whereas the other end is going to go into number 23, row 23, I mean, column B. Placed just as such. Okay, let's go ahead and continue. Then I'm going to go ahead and place my LED with the shorter side, if I'm not mistaken. Which one should that be? Okay, there we go. My shorter side over on the positive right side of my breadboard on the left end, with its end finishing right at column A, exactly next to my resistor. Then I'm going to go ahead and place only one transistor this time around, flat side to the back, over on the extreme end of my circuit, which means, if I'm not mistaken, it should start off at row 22 and finish at row 24. Now I gotta be careful in inputting this. I don't want to bend it, and I want to make sure that it goes in. Beautifully done, just as such. Okay. From there on out, what I'm going to go ahead and do is get one jumper cable. We're not going to need 3 this time around, and I'm going to go ahead and place the end right on column D, row 24, with its other end finishing at 31 on the positive left side of the board. If I turn it on, the light should be on, right? And that's a simple build. So what I'm going to go ahead and do to ensure that this is a NOT, I'm going to take one more jumper cable, and this time around I'm going to go ahead and place it at right in front of the middle, as well as the connector part of my transistor, just as such, to notice that the light turned off. Now it's on and it's not turning off. What I want to think of this as, I want to think of it as a switch, as a key, right? If it's off, I gotta know that this is gonna turn on behalf of this. One last time, once all is set up, and again, I block the current from my transistor, it should turn off, hence a NOT connection.